Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming.
Good morning, and you're very welcome to another Signpost Series webinar. I hope you're all keeping well and looking forward to another very interesting presentation. And this one is particularly important because it's as part of Teagasc Soils Week. Just to finish off our Soils Week, and there's been lots of events over last week, so I hope that you've got to a few of them, and we're going to hear a bit more about soils there today. As you move around Ireland or even within your own farm, you'll be very quickly discover the wide range of soils farmers have to work, each soil type with their own characteristics and associated challenges. And to tell us a bit more, we're delighted to be joined this morning by Teagasc researcher Dr. David Wall, based in Teagasc, Johnson Castle. We're also joined by Teagasc Catchment Coordinator for the buy-in, Fiona Doolan, who's going to help me out with questions. So, David, just back to soils again. I suppose there's a lot to talk about soils, and I know you're going to dig into it. Pardon the pun. I keep using that pun every time I talk about soils, but we're going to talk a lot about it. But I suppose that the first thing that we always ask, and I know your presentations about diverse soil types and how we manage them, but is it as simple as just saying, you know, we have wet soils and we have dry soils, or how many soil types do we have in Ireland?
Yeah, good question. Certainly not as simple as just wet and dry. Wet and dry is good in terms of I suppose primary picking out soils or categorizing soils for management, and many farmers will use wet and dry, but there's a lot more to it. We've actually over 114 soil types across the country, and when the glaciers retreated, so to speak, they mixed everything up, and you know, they I suppose broke down the geology underneath, the rock underneath, and created these soil types. And yeah, we have wet soils, we have dry soils, we have everything in between, but there's a lot more to it than that, which we hope to delve into here this morning.
The glaciers have a lot to answer for. If you go from one end of the field to the other, you could have extremes.
Yeah, look at it, and that's different than other parts of Europe, where it's largely homogeneous. They have miles and miles of the same type of soil. They think it's variable, but yeah, you're right. I think in one field we were doing a bit of research in, there was over 13 different soil types in it.
Yeah, that's mind-boggling, and especially if we're trying to manage a farm in one way, like it doesn't work, obviously, and I know you're going to tip into that today.
I want to talk about, I suppose, adaptive management for diverse soil types. So one soil certainly doesn't fit all when it comes to the management of soils. As we said from the outset, there's over 114 soils out there, but we don't have to make it as complicated as all that. There's key properties or key indicators in soils that it helps us to manage our soils for different outcomes or different functions that the soils might supply, or different ecosystem services that we expect from our soils. So things like food production, we also want clean water, we also want our soils to store carbon and regulate our climate. A habitat for biodiversity, which is critical and probably central to all the other functions, and to recycle nutrients, waste, etc., back into the system so we can get those nutrients back. So our soils perform these functions and many, many more for society. Obviously, they're home for our cultural heritage as well, and we build on top of our soils. Two other ones that are not really agriculture, but also important for society as well. So let's get into this a little bit. So in terms of distinguishing soil health and soil quality, this is something that comes up a lot of the time, and you know, people use these terms interchangeably, and we've endeavored in some of our research to actually put a little bit more qualification on these terms. So if we think about ecosystem service provision, and you know, the more ecosystem services provision, the more to the right of this graph that you would be moving. So if we think about a soil and its capability to perform these ecosystem services or to provide things for society, you know, they're defined by the soil type itself, maybe the climate that is in, and I suppose soil quality then provides a definition for that capability of the soil to provide these ecosystem services. However, when we think about soil health, we think about the current capacity. So the capability, if you had long time frame, the soil might be capable of delivering more than it is at the moment. But under current management, with people, we want profit from our soils in terms of agriculture. We want the soils to perform for the planet. So there's compromises to be struck there. And we call soil health, or the current capacity of our soils to deliver. And, there's sustainable soil capacity, and then there's unsustainable soil capacity. And when I think about unsustainable capacity, if we radically change our soil to be something else, something that it's not, or if we put things into our soil that makes our soil different from what we set out with. And there are man-made soils out there, and that's not something that's really sustainable in the long run. For defined uses, etc., we might modify or change our soils for building or for something else. But typically for agriculture and the broad scope of our soil landscape, we're not going to change those in any radical way. So just in terms of a definition, then, soil quality describes the capability to provide ecosystem services by performing vital functions for a given soil type under climatic conditions, whereas soil health is the current capability of the soil to do those things under human and current management by humans on that soil. So with the plants, the animals. So if we're for example, in a defined farming system, that's the land use and what has been decided for that soil type. And then how good can we make that soil under that defined land use and under that defined management system? So that's the challenge. So first of all, we need to assess the health status of our soil. So, if we don't assess it, how can we manage it? So you measure first and then you manage according to what you measure. So the key question here are, what are some indicators that we can use to tell us a little bit more about how our soil is performing, what the health status of our soil is, and then, based on what those indicators tell us, we can come back and say, okay, this is a little bit subpar. Let's do something. Let's intervene here. Let's change our management to get those levels up in terms of that indicator. So if we think about indicators in the Square project, which was run over a 5-year period, we looked at a range of indicators across soil types right across Ireland. So we travelled from the southeast to the northwest, from the southwest to the northeast, and everywhere in between. Going into farms, looking for soil types that had been identified through the soil survey back in the day, and we took a range of indicators across many different areas. So soil structural indicators, things like visual soil examination, bulk density, physical quality, and those visual assessments, grass vests, and the double spade method for arable soils. These allow the practitioner or the farmer or the advisor or whoever it is to take the soil out of the ground with a spade, have a look at it, and identify key parameters such as aggregation in the soil, the physical shape of those beds, etc. Those can tell us a lot, root structure, etc. Primary productivity and carbon cycling, what are the key indicators for those? So we took crop and grass yield and quality. That's a key indicator of primary productivity or production. Soil organic matter stocks, carbon associated with soil aggregates. Those are key there in terms of carbon cycling, carbon sequestration, and I suppose carbon dynamics in soils, which can be short and long term. Nutrient cycle and biodiversity. So Obviously, for nutrient cycling, you would look at the chemical health of your soil, the biochemical properties, the microbial communities. I think Fiona discussed some of this in the last webinar. And there's cutting edge technologies now that we're using in soils. We're also using them on humans. We're using them in medicine, etc. But we can apply these in soils, looking at DNA, looking at RNA. To look at the microbial community that's there, and also to find out, I suppose, who's there, how many are there, but also what are they doing, what's their function. And that's, I suppose, the Holy Grail. If we can do that and capture that information through research and then disseminate that out where we know what those microbiological communities are doing, etc., that will be a huge step forward. And then finally, in terms of water and other aspects of biodiversity, terrestrial biodiversity, etc., we have indicators like how well will your soil drain or hold water, hydraulic conductivity measurements, but botanical measurements, earthworms, nematodes, abundance and species. So there's huge indicators, number of indicators there that we can look at and that we can physically see. We mightn't be able to see all the microbiology, but we'll be able to see those larger species, etc., in our soils. So once we have our indicators, we soil sample as the first step, and that can be different. We can do it at random, we can do it in a more structured grid pattern, or we can do zones in terms of different soils in different parts of the fields. And each has their own merit. Probably grid sampling for survey. However, we're probably sampling in zones when we're sampling farms. We want to know if one soil type is different than another soil type, or in a field, if you have a bottom area of a field versus the broadacre top of the field, there might be two different soil types in it, or down near the river. So there's different sampling schemes. We have a selection of indicators, and a selection of indicators has been proposed by the soil monitoring law that's been looked at a European level at the moment. However, how do we set targets or thresholds for these indicators? And there's a number of methods to look at thresholds. So obviously, if your indicator is very, very low, you're in the red, you're not in a good place. But we want to define a critical threshold for that indicator that under a certain management, under a certain desire of that landowner, that they don't fall below that critical threshold where function and ecosystem service delivery becomes drastically reduced. So that's the minimum. However, we also want to set a target that we want to achieve over time. So we might be somewhere in the middle currently, but if we don't set a target, it's very hard to move up and to improve soil health and management without setting some kind of a target or some kind of a goal. And there's a number of ways of doing that. We can use fixed values. So those from published or robust values from science, but we have to question, are these always fit for purpose for my soil, in my context, in my area? So that research might have been conducted elsewhere, even in another country, and those targets may not be achievable or may not be optimal for the context that we have here in Ireland, or even locally in terms of a different soil type. There's natural. Can we ever go back to the natural reference situation? So where man has had little influence, and in a farming situation, that's probably not desirable in terms of trying to get back there. It's probably unattainable in any stretch anyway. And typically what we're trying to do is, we've decided on the land use. We've decided that this land is going to produce food as its primary function and ecosystem service. However, can we get those other ecosystem services to be performing at a reasonable level, and there's always a compromise. So the natural may not be always the desirable reference situation. We can use a distribution based on soil in the region. So where we sample a local population of soils in a region and we say, okay, the top 25% have these levels. Let's try to set that as our optimal target. And then obviously relative change over time. So you might have started here in the red situation, and over time we're measuring our progress relative to that starting point. So all of these are valid for different situations. However, you need to pick what's appropriate for your situation, or here in Ireland for our situation and context, weather, climate, etc. And the FAO have come out with voluntary guidelines for sustainable soil management, and they're saying that sustainable soil management, that it is sustainable, the management of soils, if the supporting, provisioning, and regulating and cultural services provided by our soils are maintained or enhanced without significantly impairing either the soil's functions that enable those services or biodiversity. And it's key there that they've brought in biodiversity as a key function or a key property of our soils. And you know, it's been described as the engine room. If we think about mineralization of organic manures that we put out, if we think about the breakdown of some nasty pathogens, etc., that are there in our environment, etc., biodiversity are central to solving those issues for society, but also providing, I suppose, the nutrients, etc., that we all need to grow our food. And there's a long list. I don't expect anybody to read this. But the soil monitoring law has come out with a list of principles, sustainable soil management principles. It's taken them a long time to agree on these principles and all the countries involved. However, there's a few things that are worth mentioning here. So avoid leaving the soil bare. So, you know, we need to have plants growing on our soils for the majority of the time. That's providing carbon, pulsing into the soil to feed the biology, etc. Plus, it protects the soils from erosion, etc. Minimize soil physical disturbance. So the less we disturb the soil, the better the structure is going to be. Avoid harmful inputs. That's fairly standard. Ensure machinery use is adapted to the strength of our soil so we don't compact it. You know, in terms of fertilization, ensure adaptive to the needs of the plant, crops that we're growing that we're not supplying too much or we're supplying a good balance. Maximize the efficiency of irrigation systems. That's for elsewhere in Europe and the world. We don't irrigate that much here. Who knows, in the future with climate that may grow. You know, maintain the landscape features. And site adapted species. We don't want to be growing species or putting species of plants into our soils that are not either not native or also not adapted for the soils and conditions that we have. You know, in terms of water levels, crop rotations, and livestock management, these are all principles of sustainable soil management. And probably, to be fair, most of these principles we adhere to them or we follow them in some shape or form in everyday farming here in Ireland. You know, we are grass based and we're very focused on the soils on the livestock side of the house, and also in terms of the arable side. You know, we grow our crops for the markets that are there. We try to have a crop rotation, and there's organic manures, etc., going back on our arable soils or our tillage soils, which is, you know, abiding by many of these principles. However, do we have the available knowledge in terms of all these areas of sustainable soil management practices? And this is a snapshot of a European study, Ireland included in this study. 27 countries responded to the survey, and we can group the soil management practices that were the survey sought responses to into 4 main areas: crop and cropping systems, soil nutrient management and crop protection practices, soil trafficking and tillage practices, and then water management practices. And you can see here in terms of the responses that we know most about soil nutrient use or soil fertility. We know a lot about maintaining and increasing soil organic carbon, and we know a lot about physical structure in terms of improving structure. And as you can guess there, tillage, etc. There's a lot of work has been done there in terms of the brown responses here that would correspond to soil trafficking and tillage. However, when we get down to biodiversity, enhancing water storage, and avoiding soil erosion, we know somewhat less. The responses here are not going to the right as much. And then when we get down to these other areas, in terms of challenges for soils, contamination, minimizing greenhouse gas emissions, avoiding salinization or acidification, which might be more pertinent in drier climates, there's little known, few studies, and much less known. So again, research is working to develop more knowledge. However, it's also up to the practitioner, I suppose, to take that knowledge on, become more au fait with what are sustainable soil management practices, and then to implement those if at all possible under systems. And now I'm going to get into some of those practices. So when we're selecting a practice, we need to think about the context that we're in. We also need to think about what we want those practices to deliver. So many people start down here at the bottom in terms of sustainable soil management options, and they just pick a management. However, we need to think about the soil types, the climatic zone that we're in, etc., to see if that practice or that new option is really going to work. And then also, what do we want our soils to deliver? So for farmers, maybe primary production is their key objective, but they also want to recycle the nutrients that are there so they don't have to spend too much more money on expensive fertilizers. At the moment, water cycling and water quality is critical. So any farmers out there that want to maintain irrigation, want to maintain, if they're on a group water scheme, they want to clean water to drink, etc., clean water to wash down the bulk tank without pathogens, etc. That's critical. Carbon sequestration has come to the fore from a climate perspective in recent years, and obviously trying to mitigate the effects of climate change. But also, we want our soils to be healthy. We don't want to be burning up too much steel when we're working our soils, etc. And carbon and soil organic matter are critical in that respect. And obviously, we want to maintain a habitat for soil organisms that help us every day when we're farming. If we think about an earthworm, it's nature's plough. But also all those organisms that we don't see every day that are doing Trojan work to help us in our farming pursuits. So again, we do need to think about all these aspects when we're selecting sustainable soil management practices, especially ones that are going to have a positive effect. When we get into soils then, how can we categorize our soils for that management? So as I've said from the outset, with 114 soils, we're not going to do different management practices, 114 different management practices per se, because we have different soil types. Can we group our soils with similar properties around similar managements that are going to be suitable for those soils? And we have lots of information. We have surveyed the soils of Ireland. We have that in reasonably high resolution. It's not at field level, but certainly with the trained eye, your advisor or an interested practitioner or farmer will be able to tell this is, soil X, Y, Z, or these soils have these properties compared with these other soils on my farm. So that information is out there in terms of the Irish Soil Information System. And if you go online, you can look up tons of information in terms of your local soils. But if we break that down into a couple of key soils, if we think about light soils, and this is the ladybird version of soil science, but important nonetheless, if we think about soils in this way from the practitioners. So if we think about a brown earth, it's similar top to bottom. It's fairly free draining overall. So, water retention, it's not going to pond or pool or be wet. It'll dry out at the shoulders of the year, but also has potential to carry some nutrients with it in terms of leaching. So we would manage that different maybe than a heavier soil. It has less clay present and, more sand and silts, hence a lower cation exchange capacity. And cations are things like calcium, potassium, magnesium, nutrients that we want our soils to give back to plants and animals. And if it has a low holding capacity or exchange capacity for those cations, then hence we would probably apply a little and often approach to those nutrients. And it also, in terms of the environment, has low nutrient runoff potential in terms of phosphorus because the water infiltrates. If we think about a heavy soil, so this is the opposite. It might be a glacial. So it has a high clay layer present at depth. Hence, the water is going to fill up on top. And once it can't get through anymore, it begins to flow off the surface during periods of heavy rainfall. However, that high clay present confers a higher cation exchange. So it will hold cations. So if we had to take a bit of a break because of price or because of lack of investment or whatever in terms of soil fertility, it'll give back. It'll hold its soil fertility for longer. Obviously has lower leaching potential in terms of those leachable nutrients such as nitrogen or nitrates. However, does pose a risk in terms of nutrient runoff in terms of overland flow. And also, because it's wet in the surface, it has higher potential for nitrous oxide gas during the spring and early autumn when soils are wet. So a very different soil and obviously will take different management. In terms of the final soil then, the organic or a peat soil, this is a totally different soil. It's high organic matter all the way through, which means that it has limited sand, silt or clay present, limited mineral matter present. Hence, from a soil chemistry perspective, you wouldn't build soil fertility on this because there's nothing to hold it. So you would add feed to yield type soil fertility, drip feed it in over the season and then stop once you would house stock or you would finish growing your crop. You wouldn't try to build it up. Has high C loss, carbon dioxide loss, if it's heavily drained. Obviously, it's full of organic matter, and if you drain it and let the air in, the soil biology will say, okay, we want more food. Carbon is our food, so let's start chewing up that carbon and releasing soil carbon dioxide. High potential for N2O loss if you're applying nitrogen fertilizers there in wet periods on this, and the phosphorus can be lost through runoff if it's flooded, but also through the drainage because there's nothing to hold it. So a very different soil in terms of management, yet a very productive soil overall if it's used for agricultural purposes. Okay, so moving along, how can we take these managements then, put them together on those soil types to come up with a level of intensity that we're using. And we can't take a management in isolation in terms of looking at that intensity. So in a grassland situation, we could have grazing, we could have mowing, we could have fertilization with fertilizer and manures. And together on top of that soil type, that will give us a land use intensity on that soil. And, then we need to assess, is that intensity too much, too little? How's it affecting soil health overall in terms of whatever aspects we want to achieve? And some results in terms of Irish studies. Soil physical health, where we look at well-drained soils versus poorly drained soils, and we have a high land use intensity on grassland versus a medium land use intensity in both. And the first indicator we're looking at here is the level of soil compaction or risk of compaction through soil bulk density. The green area is probably where soils are typically good soils, mineral soils in Ireland, under good management. That's where we want soils to be in the around 1, a bulk density of around 1 grams per centimeter cubed. And we can see there, in terms of the well-drained soil, because it's well-drained, because moisture levels are kept low because it can drain, even at the shoulders of the year. In terms of a system that we looked at across farms all over Ireland, we can see there that the well-drained soil has a lot more resilience, even under a high land use intensity on grassland. However, when we look at the poorly drained soil, because it's wet for longer, because of that impeded clay layer at depth, we're often working these poorly drained soils, especially with traffic, machinery traffic, under less optimal conditions, and hence bulk density increased there. So it becomes more compact. If we take another indicator, soil organic carbon, again, the well-drained soil, good levels of carbon overall, probably a little bit lower than on good management under poorly drained. That's because of drainage, etc. And more resilient in terms of holding onto it, because that carbon can travel deeper into the soil with drainage, etc., where it's stored for longer. However, in terms of the poorly drained soil, where there's lower porosity because of compaction, lower aggregate stability, that leads to poor root penetration in that poorly drained soil, and hence carbon can't be pumped deeper by the plants through photosynthesis, and hence has lower carbon storage, especially at depth. So again, different managements, you have to mind these soils in a different way. If we look at soil biodiversity then, and here the poorly drained soil, because there's lots of carbon in there in those poorly drained soils, had higher microbial biomass P overall, so higher microbiology, soil structure quality, labile C, a lot more food, and soil fertility were affecting soil biodiversity. However, when we go to the well-drained soil under medium land use intensity, because we're not growing maybe enough as much, we're not pumping as much labile carbon through photosynthesis, we mightn't be using as much nutrients on these soils, or there mightn't be as much manure or dung pats coming out the back of the animals to feed the bugs. We ended up with lower soil microbial biomass there. So we have to take each soil in its own context and assess these indicators in a different way. Further evidence. What happens when we stack different managements practices for improving different aspects of soil health? So what we're looking at here was soil structure, plant available water, and soil erosion and water runoff as three soil states or soil properties that we're interested in. And the managements here were organic amendment application, organic manures, reduced soil disturbance, so reduced tillage, for example, and maintaining wintergreen cover or cover crops. And we can see here in terms of the effects, the larger the bubbles, the larger the effects, or the larger the evidence is for the effects, and then the colors, brown is beneficial, the beige is neutral, and the blackish brownish color is more negative or detrimental in terms of the outcome or the soil property that we're interested in. So if we look at organic amendments, by and large, they're the brown color, so they're beneficial. However, in terms of soil structure, probably some of the application in terms of heavy machinery can be somewhat detrimental. So while the amendment itself is doing positive work in terms of soil structure, you're putting in that soil organic matter, the method here often is less desirable at certain times of the year. In terms of plant available water, we know that soil organic matter holds a lot more water than the mineral matter, than the sand, silt, and clay by itself. So again, that's having a very positive effect on plant available water, and really important through droughty weather that we're having more recently through the summers. And then in terms of water erosion and soil erosion, or water runoff and soil erosion, a large positive effect in terms of organic matter. Obviously, the organic matter is like the glue that holds the soil particles together. It also promotes, I suppose, more biological activity in the soil there, which helps to build structure, improves drainage, etc. So again, by and large, organic matter gets a positive vote. If we look at reduced soil disturbance or reduced tillage in this area, bulk density and soil structure was actually negative in terms of reduced tillage. Now, if we look at these studies, by and large, heavy machinery in terms of that reduced tillage, maybe working systems, especially in wet climates like Ireland, if we're not practicing that at the ideal time, we may end up with more soil compaction at depth under reduced tillage systems. So really, really important that reduced tillage is practiced in the right circumstances. In terms of plant available water, largely positive. And then in terms of water runoff or soil erosion, neutral. It was neither positive nor negative in all these studies. And there was thousands of studies looked at in this piece of work. If we move then to cover crops, we can see they're largely beneficial in terms of soil bulk density or soil structure, especially having a root during that winter period. In terms of plant available water, a small negative in terms of plant available water, and probably more relevant in drier climates where they need to store the water over the winter so that they'll have it for the subsequent main crop. And that would explain that one. And then in terms of water runoff and soil erosion, largely really, really positive. And obviously having that green cover takes the energy out of the heavy rain over the winter before it impacts the soil and causes dispersion, and also it's using up more water through evapotranspiration there in the winter, so soils don't become waterlogged, etc. However, one caveat, these relationships with soil management practices are often specific to a specific location, soil type, and climate. So again, we must take whatever management practices we select within the right context. Synergies and trade-offs between soil management practices. So if we think about reducing soil disturbance, maybe diversifying our cropping systems or increasing organic matter inputs in our soils, the synergies for these are maintaining soil structure, preserving soil biodiversity. However, are there potential trade-offs such as increasing greenhouse gas emissions, where we have more soil organic matter or our soils are wetter for longer? Or do we enhance nutrient losses by taking on any of these management practices. And we look into this in terms of, again, taking scientific studies from Ireland and Europe, but also wider across the world. 533 studies were looked at. We looked at these management practices across these studies, and we wanted to see whether the change in soil organic carbon was an increase, there was no real change, or a decrease overall. And if we start with diversifying agroecosystems, by and large, about 34% of the studies showed an increase, and the remainder of the studies were largely neutral, neither increased or decreased. And that could be because of other management practices that were happening, as well as the diversity in terms of multi-species swards, for example, in grassland, or growing cover crops, as well as your main crop, or in some parts growing, having multiple crops or combined crops in the one system, inter-row crops, etc. In terms of minimizing soil disturbance, this could be direct drilling, it could be stitching in, such as oversowing clover into grassland swards, into ryegrass swards, or it could be a min-till reseed, etc. So there's multiple ways we can minimize soil disturbance. By and large, we had 34% of the studies again were increasing. However, 72 studies, or 65% of the studies, were largely neutral. So it's not necessarily the direct route to increase in soil carbon, depending on what other management practices that we do. And, as I said, in what we looked at in terms of the compaction study, it mightn't be necessarily reduced tillage that we're after. It could be doing less traffic or trafficking at the right times of the year that might be more important than the tillage per se. Increase organic matter inputs. This is overwhelmingly positive for increasing carbon. 70% of the studies showed that if we can increase organic inputs through whatever means, so through straw, through organic matter, or through more grazing rather than harvesting and cutting, it's shown largely to be quite positive. About 29% were neutral, and very little of all these three management practices were negative in terms of carbon. So sustainable management practices are not equally efficient in sequestering carbon. However, we must think about the context that we're doing them in. So, there's different strengths to different management practices.
Just let you know, David, you're a bit tight for time there now.
Yeah, nearly there, Cathal. So in terms of soil structure versus lower soil carbon, higher soil carbon, so improve soil aggregation with better structure, increase soil porosity, enhancing water penetration, reducing soil compaction, and abundant and diverse soil biota. So more food equals build it and they'll come. If you have more food in your soil, you'll have more biodiversity below ground. And again, soil organic carbon is critical and a critical indicator to soil health overall. So the last area that I'm going to talk about is soil structure when trafficking soils. So this is a study that we conducted in Johnstown Castle, and we looked at trafficking with a slurry tanker with trail and shoe, fully laden at different times of the year. So spring, summer, autumn, and winter, under different soil moisture regimes. So when the soil was waterlogged, SMD is minus, or soil moisture deficit is minus. At field capacity, when the soil has 24 hours to drain following rainfall, or when the soil is dry. And you can see here, when soils are relatively dry, no problem, even in winter conditions when soils are fairly fairly wet or after getting a lot of rain in recent times. But when they're allowed to dry, and we look at SMD of about 8 to 10, there's some risk, but much less of a risk. If we go to waterlogged conditions, you can see there, even in the summer, we got conditions where there was irreversible compaction happening at depth. And I'll show you this in the next slide. So summer trafficking, we can see there in terms of the lines correspond to dry, moist and wet. So if we look at the control soil here in the solid line, this is dry and this is moist. And you can see here in wet, even in the summer, when we're waterlogged, we can see here the bulk density is largely increasing to unsustainable conditions. Less so at depth because the soil is dry. However, if we go to winter trafficking, even at the surface, if we think about the waterlog being the worst case, but also a big increase here at the surface during winter conditions for both dry and moist. However, the big issue here is at depth, all of these soils are increasing compared with the control, and even this waterlogged situation has lost integrity. It's lost its structure altogether. So again, we need to think about at the surface, but we also need to think down here 20, 30 centimeters below ground, what's happening as well when we're trafficking. And to finish up then, some recommendations for maintaining and improving soil health when it comes to sustainable soil management. First of all, we need to assess soil health in order to make decisions on more sustainable management. Both visual soil assessment, so take out a spade, is a primary method to assess your soil. You'll be able to see what's happening below ground. You'll be able to see where it's tight, etc. And also, we have soil tests on most farms now, and that's a key indicator for how healthy your soil is. Do you have a balanced nutrition? pH, I would say, is a key indicator there, and it's a regulator of many functions, both chemical, biological, and then indirectly physical as well. Maintain a year-round soil cover, or as close as possible. In a tillage situation, you won't have year-round soil cover, but there's always opportunities to put on cover crops or to promote green cover, natural regeneration in soils. And this will help with soil structure, soil organic matter, and also reduce erosion as our rainfall has become more energetic and severe over winter periods. Make sure soil organic matter stays or returns as much as possible. And this can be encouraged through things like that green cover, but also the addition of organic amendments. And you know, trading of organic amendments and movement of organic amendments between farms is practiced there and should be encouraged going forward. Reduction in traffic on agricultural land rather than just a focus on tillage and reduce tillage per se. I would say reduce the traffic or the timing of traffic when soils are more suitable is probably more important than getting fixated with reduced tillage. You know, if traffic in fields in unsuitable conditions, it creates and exacerbates soil compaction and is a definite no-no. And then finally, build soil resilience over time. You know, the climate is changing, farming systems and demands on our soils are changing, and we need to build resilience for the future. Healthy soils respond better to those changes. And I'm living and working here in Wexford, and you know, in the last 5 years, we've probably had 2 major droughts and every other year short and temporary droughts where grass growth and crops have been affected. And certainly building resilience is more in my mind and in the mind of many farmers that I'm talking to at the moment. So with that, I'll stop and happy to take any questions, Cathal.
That's brilliant, David. Thanks a million. Really comprehensive presentation. And I think what you really highlighted to me, it's not as much, you can't just get into the tractor, turn the key and off you go. There's an awful lot to think about in between. But something that struck me, and you finished nearly on it on the end, that building resilience, right? So for farmers to be resilient, they have to be able to make money. So, and you mentioned trade-offs as well, and there's a lot of trade-offs: biodiversity, gas emissions, water, and the bank
Yeah.
as well. How do we balance all those, or is there research trying to balance them first and advising back down to farmers, or because it could add a
Yeah,
farmer?
this is a very good question, and you know it is complicated. However, the choice lies with the landowner, I would say. Ultimately, you know, they're the ones that own the land. They're the ones that make the decisions every day. And there is compromises to be struck. We can't have everything all of the time, but what I would say is we can have a lot most of the time. And when I say a lot most of the time, if your primary goal is to farm, produce food and sell that food to sustain your family and to have a profit, there's nothing wrong with that. Certainly nothing wrong with that. That's your business. However, if we can strike a balance that we don't drive on that to the nth degree and chase something that's not going to happen in terms of that food production and that ultimate profit to the detriment of something else that's actually going to cost us money in the long run. So, you know, it doesn't make sense if we're treating the water in the local area or we're having problem with you know, somebody for example, they're doing a lot of testing there in terms of water that's used for wash down of bulk tanks, etc., in the dairy. If the water is polluted in the area, um, and we're trying to go ahead and farm at the same time, that's a kind of a contradiction in itself. So again, you know, using organic manures when we you know, buying fertilizers, expensive fertilizers, and we could be using that's eroding our profit. So there's always compromises to be struck. We might have to pull back a little bit from the brink in terms of our food production goals to get some of these other things. But when we strike that balance, we end up with a better and more sustainable system. And I think in the last year, drought in different regions of the country have made people kind of think, okay, can I carry as much? Do I need to put a little bit more resilience in the silage pit for the winter? And we need to start thinking that way in terms of our soils as well. You know, how can we store a little bit more water in the summer? How can we make our soils a little bit more resilient in terms of shorter work windows in the spring, getting cows out to grass earlier? Should I put those cows in? Should I leave them for an extra week? Will I use on-off grazing, etc.? All these things that farmers are thinking about, they may not be thinking primarily of the soil first. And I think that's key.
Yeah. Fiona, lots of questions.
There are, and I'm going to start with one that's come up a little bit, David, about nutrient management planning and soil sampling and such, and the question around the use of, you know, a single soil index for optimum across all these various different soil types that you mentioned. Would we be better off having, you know, future schemes or programs focus more on soil health and soil type in terms of recommendations and reporting on soil samples as opposed to just using index 1, 2, 3, or 4?
Yeah, no, and this is a really good one and one that comes up. So the index system is a universal index for all soils, right? It's not perfect for all soils, but in the absence of maybe you have a lot of practitioners that are not maybe identifying different soil types on their farms per se, they're working at a field level and not really taking that into consideration. So it works for that level. For that's the Division 1 level. If we want to go into the Premiership, we need to get out and first of all identify those different soils on our farms. And we have research to underpin a much more complex and much more different recommendation system. Many advisors are well au fait with this. So if I think about a piece of work that we've done recently looking at cation exchange capacity, we have three ranges, an index system for soils to put soils into three different indexes of cation exchange capacity. And if we were applying potash to those three different groups, we'd manage the low CEC soils with a drip feed versus the ones with high CEC, we'd build them and walk away. we'd build up soil fertility and walk away. We wouldn't need that drip feed. So one dose annually would work on those, whereas the other one we would need to treat much different. So we do have that information, but it takes the practitioner to have the interest and then also to take on that advice and seek that advice to be able to move into the premiership model.
You've answered my next question, which was in relation to those lighter soils with low CECs. So I'm going to move to, there's two questions here around the soil management practices you mentioned there. For example, applications of organic manures, and also the reduced tillage. Some of them have, neutral effects. Some of them have even detrimental effects on soil structure. But is that really about the machinery and the physical application of those as opposed to the actual practices themselves?
Not always. So yes, in terms of the organic manure application for soil structure, yes, that cohort was actually to do with the machinery more so than the organic manure itself. In terms of the other management, the reduced tillage, etc., that was less to do with the machinery per se, and more to do with building soil structure at depth. So basically, with that reduced tillage, you can get more organic matter at the surface. However, we don't get as much organic matter deeper in the soil. It becomes more stratified at the soil surface, and that can cause issues in its own right. Also, things like increased grass weeds, etc. So there's horses for courses. I'm not saying that it's wrong. You just need to pick your soil type. It may suit a very light soil type here in Ireland and maybe less suitable for a heavier soil type with more clay in it.
Very quick question, David. Your first slide there was about soil quality and soil health. And we've talked a lot about improving soil health, but can you improve soil quality, or do you have to deal with the cards you're dealt with, i.e. this is your soil type, you cannot change that?
By and large, that is the answer. By and large, the cards you're dealt with, the DNA of your soil, the bricks and mortar that you're dealt with is largely it. What I would say there is we do improve aspects for different ecosystem services. So if I was to say to you, you could drain your soil, put in drainage, that would change almost the cards you're dealt with fundamentally. That's not always the best thing to do, depending on the ecosystem service that you're after. So again, if it was for food production, yes. If it was to reduce the greenhouse gas N2O emissions from nitrogen that you've applied, yes, drainage would work in a mineral soil. However, if you're wanting that soil to be a habitat for different levels of biodiversity as the primary use, then drainage would actually be a negative. So,
and somewhat related to that, David, there was a question, or maybe looking for a comment from you on, the poorly drained soils. You showed biodiversity performed very well in those poorly draining soils, kind of contrary to what you might think in some aspects.
So typically, more poorly drained soils have more carbon. So they're wetter for longer. There's less natural mineralization or decomposition of organic matter, hence they build up. The extreme of that analogy is the peat bog, where it's flooded. There's no oxygen in there, so the plant matter that has grown for hundreds of thousands of years has built up over time because it doesn't decompose. But if we go back to a poorly drained mineral soil, it will have more carbon generally. Hence, more carbon equals more food, and more food equals more microbiology to chew on that food if conditions allow. So if there's air and heat at times for that microbiology to flourish, they'll be there.
Go for one more, Fiona, and then we better pull the plug, I'd say.
Perfect. I have an interesting comment here, David, looking for a comment from you on agroforestry or silvopasture, where you can see positive effects on the increased, say, for example, in grazing weeks or weeks of grass,
Yeah.
we're improving trafficability by this extra crop there. Do you have any comment to make on that, or possible
Yeah, certainly.
adaptation to that in future?
This is proven. There's been a lot of studies done in AFB and in Loughgall in particular would be the primary one where and we do have an agroforestry demonstration in Johnstown Castle as well, where we're looking at those aspects. But with trees in the system, the trees will pump more water, especially this time before they fell their leaves, etc. And with that, it helps to pump more water through evapotranspiration, dry the soils that little bit quicker, and there's weeks of additional grazing in the back end or in the spring to be gotten with that system. Obviously, they're providing other benefits there for the animals that are there, shade in times of high sun, but also shelter in more inclement weather. So again, we're looking at other aspects there in terms of what happens in terms of carbon dynamics. Can we increase carbon sequestration, not only in the tree itself, but also in the root infrastructure underneath those trees and along by the agroforestry line. So multiple benefits potentially to be gotten. May not suit everybody, but if we're in a more extensive grazing system, or if you're doing them in alleys, it may be something to think about, and there may be another revenue stream there in terms of trees and agriculture, trees and food together.
Perfect.
Unfortunately, that's all we have time for today. And I just want to thank everybody for submitting their questions. And just remind everybody that David mentioned that there was a webinar done at the start of the week, an Ask the Expert webinar on soils, where we had people from biology to physical soils to nutrient, every aspect of soils. There's multiple 5 or 6 experts there. So that'll be on the Teagasc website and YouTube there in the next week. So keep an eye on that. Just want to thank you, David. Thanks a million. That was a really interesting presentation. Lots of questions coming through. Apologies, we didn't get time to get through them all. But I think we'll have to get you on again another time, because there's an awful lot to discuss. Fiona, massive thank you for helping me out with the questions, as always. And just want to thank Yvonne Marr in the background, who helps with the running of the webinar and the management and keeps the show on the road for us. Next week, we can look forward to Teagasc agri-environmental economist Dr. Lorraine Blaine joins us to discuss adapting to changing climate, farmers' views and strategies, and that's not to be missed. So do tune in again next Friday at 9:30. But until then, slán go fóill.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.